This is a video for AQA Further Pure Mathematics, Vectors, Section 4.1, the intersection of a line and a plane.
Well, if you have a line which is not parallel to a plane, then the diagram shows that that line is going to intersect the plane at a single point, which is called P on this diagram. The other cases are when the line is actually parallel to the plane, in which case either it lies completely outside the plane, so here's the line and the plane, or it may indeed lie actually on the plane, so it's in fact one of the vectors which is in the plane itself. But failing those two, so if the line is not parallel to the plane, then we get a single point of intersection. This question then asks us to find the point of intersection between the plane pi and line L, where pi is given by the equation 2x minus 3y plus z is equal to 6, and r is given by 2, negative 3, 4 plus s times negative 1, 2, negative 3. Well, first it's always worth drawing a sketch and thinking about what the equations mean. The equation of the plane tells us that the normal is the vector 2, negative 3, 1, although in this particular case we're not going to need that. We're simply going to be substituting values into the equation as it's given. If we think about the equation for the line, what it's telling us is that for different values of s, the point which is given by that equation moves up and down this line. So what we need to do is to find the particular value of s where the equation for r is equal to the equation for the plane, or at least the values given by x, y and z. So we could think about r as being equal to x, y, z, and that's equal to 2 minus s minus 3 plus 2s and 4 minus 3s. So for the particular value of s where the plane and the line meet, then the two equations will be the same. So this comes down to working out what's the value of s at this point here. Well, we've already said that r could be written as 2 minus s minus 3 plus 2s and 4 minus 3s, and those are the values of x, y and z for the line. So substituting those into our expression for the plane pi, we get the following. We get 2 multiplied by the x value, which is 2 minus s, minus 3 multiplied by the y value from the line, which is minus 3 plus 2s, and then plus the z value, 4 minus 3s, and that must be equal to 6. So those values of x, y and z must satisfy the equation of the plane for the particular value of s that we need. Now if you work out all of that, we find that there's a total of 17 as a number term on the left hand side. So 4 from the first bracket, 9 from the second bracket, and 4 from the last bracket. And then the s component, there's minus 2 from the first bracket, minus 6 from the second bracket, and minus 3, so in total minus 11s, and that must be equal to 6. Rearranging that gives 11s is equal to 11, so therefore s is equal to 1. Once we know that s equals 1, then we can substitute that into our equation for the plane. R is equal to 2 minus 3, 4, and then s is equal to 1, so 1 times -1, 2, -3, which gives us our point P as being equal to 2 minus 1, which is 1, -3 plus 2 is -1, and 4 minus 3 is 1. So the point on the plane where the line intersects is the point 1, -1, 1. On this slide then, that's just written out neatly for you, so you can spend a little bit of time just perusing it.
That concludes this video on intersection of line and a plane. The next one we'll be looking at the angle between a line and a plane.